The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to 24 Hours That Pass, Growing Our Community. We're excited that you could join us today for Ed Leighton-Dick's session, Protecting Your Data with Encryption. This 24 Hours That Pass event consists of 24 consecutive live webcasts delivered by up-and-coming speakers and experts from the PASS community. All of these great sessions will be available next week on our website, so visit www.24hoursofpass.com. My name is Vicki Van Dam, and I am the Operations Manager at PASS HQ. I have a few brief introductory slides to begin with before I hand the reins over to Ed. Ed will then speak for about 40 to 45 minutes, and at the end of the session we'll have some time for Q&A. So most of our questions will be holding until the end. If you have any problems during the session, you can just type a question into the question pane in the GoToWebinar control panel, and I will be there to help you out. You can also maximize your screen, and you can use the Zoom button located at the top of the presentation window to adjust what you're seeing. Feel free to enter any questions into the Q&A field at any time. That question pane is located on the right-hand side of your screen. Once we get to that portion of the session, I'll read your questions to Ed, and you won't be able to speak since all attendees are muted. There's also a short evaluation at the end of the session. Your feedback is very important to us and to our speakers, so please take a moment to complete it, and it will just pop up on your screen at the end of the session. I'd like to take a moment to thank our presenting sponsors, Microsoft, Cisco, and Dell Software. I'd also like to thank our support sponsors, SQL Sentry, HP, and SolarWind. The staging of 24 Hours That Pass would not be possible without their support and dedication, and they are the reason that this event is available to our community free of charge. So thank you, our sponsors. Next, I'd like to bring your attention to the upcoming PASS Summit. Taking place in Seattle, Washington from October 27th to 30th, PASS Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, PASS Summit is single-handedly the largest gathering of SQL Server and BI professionals in the world. With over 5,000 attendees from all across the globe, PASS Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, PASS Summit delivers on providing you with the answers to your SQL Server issues, along with knowledge, strategies, and skills you need to stay ahead of the curve. Contact your local chapter for more information and for a discount code to save $150 off your registration. Optimize your savings by registering before Sunday, July 12th. To find out more, visit www.passsummit.com. With that, I'd like to introduce Ed Leighton-Dick. Ed is a 24-year veteran of IT. He's got 16 years experience with SQL Server and 9 years experience as a DBA. He comes from a development background. Ed is currently the founder and principal consultant of Kingfisher Technologies, and he volunteers with the PASS organization as both a chapter leader and a regional mentor. He's a speaker and an active blogger. If you want to connect with Ed, you can see his details on the right-hand side of the screen there. So without any further ado, I give you Ed.
Thank you, Vicki. And I have to say it's really a thrill for me to be able to speak with you this morning on 24 Hours of PASS. Thank you for coming. This session is about protecting your data with encryption, and it's got definitely a development slant to it. As I said, I've come from a development background. I know a lot of the challenges that developers face, and one of those definitely can be convincing people that it's worthwhile to spend the time to put things like encryption that don't necessarily offer tangible benefits to the customers into our software. But given the security environment that we've been facing, especially in recent years, it's becoming more and more important for us to build encryption into our software. So I'm going to start out today by just talking briefly about why we really need to use encryption in the first place, just to give everybody a common point of reference to go from for the rest of the talk, and some bullet points that you can use to go back to your managers and your executives to promote it in your organization. Then we're going to talk about the 3 general types of encryption that's supported by SQL Server, at least through SQL Server 2014. There's some new enhancements that are coming in 2016 that aren't covered in this talk, but most of them will be the same going forward. Most of that we'll talk about in column encryption because that's really one of the 3 that developers can affect on their own. And then finally, I'm going to spend a few minutes talking about how you can protect your keys and why it's so important to protect your keys. So starting out, why should we use encryption? As I mentioned, it's become more and more common for us to be seeing in the news all of these stories about the data breaches. It seems like hardly a week goes by anymore that you don't see one. And frankly, doing research on security, I'm seeing a lot of them that aren't even picked up by the major media outlets. Traditionally, most administrators focused on what was called perimeter security. And for many years, that was good enough. This is a very simplistic diagram of what you might think about when you're talking about perimeter security. Simply put, on the line or on the path going from your company's network out to the internet, or even from your personal network at home out to the internet, you'd have 1 or more devices that would prevent an outside intruder from getting into your network. You probably have a router, you might have 1 or more firewalls, you might have things like an intrusion detection system. There's a number of other appliances now which you see in enterprise security which will ostensibly protect your network and keep anybody from getting into it. However, there's 2 problems with this approach. One is that if somebody does manage to breach the router, the firewall, the IDS, and so on, with a traditional perimeter-only network configuration, then they have free reign to go wherever they want to on the inside of your network. The other is authenticated users. This sort of a setup does nothing to stop an authenticated user, either by accident or maliciously, from doing what they want to on the inside of your network. And so in a modern security situation, you need to have a number of different layers to your security approach. Encryption can be one of those. In 2014 alone, ZDNet reported recently, based on a study of IBM, that in 2014 alone, over 1 billion records, that's a billion with a B, were leaked in one way or another. This is a massive increase over 2013. This is the diagram you see on your screen now is a diagram also produced by ZDNet. It's part of this article based on that same IBM study. The number of attacks that they showed in 2014 is skewed a little bit because they began including Android vulnerabilities that year. However, there was still a sizable increase even without the Android numbers between 2013 and 2014. Most of these attacks were against U.S. companies such as Anthem. Very few people have not heard of the Anthem breach in the United States. Over 80 million records of insured people were leaked. They were stolen by hackers. All of this data was clearly readable in their database. They hadn't chosen to use encryption. They saw the business risk. They knew about the business risk, but they decided it was not worth the effort for them to override the business concerns that they had about making sure the information was usable in whatever method they needed to use it, whether that was reports or whether that was showing it on the screen or what have you. Many corporations have traditionally had this approach. They'll balance that many have not seen the necessity of using encryption. But with all of the high-profile breaches, it's looking better and better to a lot of companies. Why? So encryption will protect us primarily against one thing, against mass data theft. It won't protect against everything. As I mentioned, authorized users. Authorized users will still have access to all of this data if you do your encryption well, because you will decrypt it only the records that are needed and only when they are needed. Social engineering, which takes advantage of the willingness of authorized users to help out a person on the phone or via email, will also not be mitigated by encryption. This is just one layer in your overall security scheme. However, because if you lose that data file, you lose a backup tape. If those are encrypted, it drastically reduces the likelihood of that data being useful to the attacker, and in most cases, it will keep your company off of the front page. You won't hit every major media outlet like the Anthem breach did, like Target, like Home Depot, like Sony, like all of these others that have been happening over the last couple of years that pretty much everybody knows about. And frankly, that is a very powerful selling point to executives. One of their primary goals is to make sure that the company is represented in a good light. And so that can become a very useful tool when trying to convince them that, hey, we need to spend the time, we need to put some roadblocks in our own way in order to encrypt this data to be able to keep a reputation good with our customers. When you're thinking about implementing any sort of security, including encryption, you've got two primary goals. And it sounds a little bit cynical, but one of those goals has to be to make your company a harder target than the company down the street. That actually goes hand in hand with making the stolen data useless without expending significant resources, because most of these encryption schemes, if you're using any of the newer ones, take a lot of computing power to even break one record. And so most attackers are not going to be willing to spend the time to break through multiple layers of security to try and decrypt some of this heavily encrypted data, because there are so many other easier targets out there. And right now, there are many, many easier targets. Encryption can go a long way toward making your company harder to attack. So on the surface, this sounds really hard. Traditionally, it has been, and to some extent it still is, although it's a lot easier than it used to be. It's not as hard as you might think, though. Most languages, including SQL Server and T-SQL, do have built-in support for most encryption schemes now. And day-to-day management, once you get it set up, is actually fairly minimal. Most of the things that you'll have to do with encryption going forward are implementing the same pattern in other locations, and if you have a really well-run encryption program, you'll rotate your keys occasionally. And that's really about it. There's not a whole lot to worry about as far as day-to-day management. So, going off of that, let's talk a little bit about in-column encryption. As I mentioned, this is the type that most developers will use most of the time. And there's a few different types of this built into SQL Server. SQL Server doesn't admittedly support all of the possible encryption schemes out there. Microsoft has chosen certain ones which work best within SQL Server. However, it is still a powerful tool set. One that most of us will recognize is a hash. Hashes are very, very fast. They're one-way encryption. And by one-way encryption, I mean that you can encrypt the data, but you are not able to decrypt the data. You cannot derive that original phrase from the encryption, from the encrypted phrase. One of the most common uses for this, and one that most of us will recognize this from, is a password. Most databases hash the passwords so that they cannot be unencrypted, and it makes the passwords that much more secure. So let's jump over to a demo. All right. So this uses a little demo database on an isolated test SQL Server that I have. And all of these scripts, if anybody wants to test any of this, are out on my website. And so I'm going to go ahead and just tell it to use the encryption demo database. And the first thing to do, anytime you're talking about encryption, is to create a stored procedure. This makes it reusable. It also makes it so that somebody who doesn't have an intimate knowledge of the encryption or who may not have complete access to all of the keys necessary can still use it. To create a hashed password or hashed phrase, use the hash bytes function. And it takes two parameters. The first one is the encryption method that you want to use, or the encryption algorithm. In this case, I'm using the strongest one that SQL provides in SQL Server 2012, and that is SHA-2 There's about 7 or 8 of them available in that version. Different versions of SQL Server do support different algorithms, so just check books online to find the one that you want. But always lean toward the strongest one available in any type of encryption that you do. The other parameter it takes is the phrase that you want to encrypt. So let's create this. And now we'll go ahead and we will create a user. I'll show you what the encrypted phrase looks like. So with the pointy-haired boss is the first one that created his password, and he just used a password of password because he likes to keep things easy. And this is the way it actually created the hash. A long string that looks to us like a random string of letters and numbers. It's actually hexadecimal code, as most of you will probably recognize. SQL, anytime you do an encrypted phrase, you want to store that as either a binary or a binary value in the database. Now if we create a few more and look at those, we see a couple things. For every password that you see here, you see the encrypted phrase, and they're all different, except for these two that both have the password of password. One strength of a hash is that anytime you pass the exact same phrase in to be hashed, it will return the exact same result. That's a strength because that means we don't actually have to decrypt that password in order to be able to find out if the person is using the same login. However, that's actually also a vulnerability. And this gets into what we call rainbow tables. A rainbow table takes advantage of that ability to generate the same hash from the same phrase. What a hacker will do when they're creating a rainbow table is they will start running down through all sorts of values. Basically, they'll start at the beginning of the alphabet, at the beginning of numbers. They'll just start putting together various possible combinations, trying to hit as many as they possibly can. And then for that algorithm, they will store the hash. And so in this case, I've mocked up a very simple example, but what they would do is they would store this in a table. And that table is called a rainbow table. Now when they want to try and break into a system, all they have to do is start trying these values repeatedly and seeing which ones actually hit. And using the computing power available to us now, that actually can be done very, very quickly. So what is recommended anytime that you use hashed passwords or any other hashed values is that you do what's called salting the hash. And put simply, salting is just adding another value to the original phrase in order to make it a little bit harder to guess what that value actually is. So we wouldn't be able to log in, for example, with just the word password. If we were trying to break into it, it's going to have another value in there. In my example here, we're going to hash the password with the ID. And so in this case, it would be something like password 1 or password 2 or password 1477. Something like that so that it does not generate the same value as the word password. So if I execute that and show you what it does, now if you look here, we've got 4 different people who have all used the word password, first that we created before. But now we've got Bob and the garbage man. And their hashes are different because when we hashed their password, we added that salt. Now in this case, I used the ID as I mentioned. That's not a fantastic value to use as a salt. It works for a demo. But what you would want to do is you'd want to find some sort of value that's going to be consistent, because obviously if you change that value and try to look it up, and it's changed since the password was salted and stored, you're not going to be able to retrieve the same value. So it's something that needs to be consistent. It's going to be something that needs to be easy for you to find, but hard for an attacker to guess. And you want to make sure that it's going to be variable based on each row of data. So you wouldn't want something, you could use like a department number, for example, but you wouldn't want to use the same value. So for example, your company's zip code or something like that, that's going to be the same for every row, because that makes it easy to guess. One final thing on hashes very quickly. This is an example of what you might do to retrieve that and to look up the password to compare it when somebody's logging in. Basically, what I would do is I would do something like an isNull function in an inline table valued function, so that we're just going to return that very simple, I'm sorry, it's not table valued, that's a scalar function. Return just an isNull, 1 or 0. Either it is or it is not the password. You don't want to return too much. This is why you see a lot of websites that only say your login is incorrect and doesn't help you as to whether it's your password that's wrong or your username that's wrong, because we don't want to give too much information to a potential attacker. Okay. The other type of encryption that we can use within a database is reversible encryption. The first type we're going to talk about is a symmetric key. Symmetric keys are very fast. Not as fast as a hash, because the algorithms are getting more complex, but they are fast. The same key, which can be a password, will encrypt and decrypt. And so we can use that for securing data, because it is fast enough to be used on 1,000 rows or 10,000 rows or 100,000 rows. But that limits its usefulness, because you wouldn't be able to give this encryption key to somebody else. So you should, in your database, you should secure that by some other key, and you can actually encrypt it by multiple other keys at the same time. And that becomes useful when you need to rotate your keys for one reason or another. One other drawback to using a symmetric key is that it can't really be backed up. However, like a hash, if you pass in the same password to create the symmetric key, whether that's a password, whether it's a certificate or something else, if you pass in the same thing to create the symmetric key, it's going to produce the same symmetric key in the end. And so that is probably the best method that you can use to back up your symmetric keys, is to store what you use to create it. The other type of reversible encryption supported by SQL Server is called an asymmetric key. Asymmetric keys are familiar to most of us. That is the same type of a key that's used, for example, in SSL. When you hit a website that is secured, that is a form of an asymmetric key. It's also called public key encryption. In an asymmetric key, you have one key that encrypts or encrypts the data. That one can be shared because all you can do with that key is encrypt the data. On the other side, you have the private key. That is able to decrypt the data. And like the name suggests, you want to keep that to yourself so that nobody besides you, nobody that's unauthorized, is able to actually decrypt that data. The problem with this is that because the algorithms for this are so complex, it becomes fairly slow to use. And so it's not necessarily suitable for encrypting large amounts of data on its own. However, you can actually use it to encrypt a symmetric key. At that point, you're only using the asymmetric key once, and then you're using the faster symmetric key in order to actually encrypt and decrypt your data. There's a special type of an asymmetric key built into SQL Server, and that's a certificate. These conform to a specific standard called X.509v3. If you've ever submitted an app to an app store, you've used an X509 certificate. It's also called a code signing certificate. Microsoft releases those under the Authenticode brand. If you get one of these from a third party, most of the time they will have an expiration date. You can also import and export asymmetric keys, which enable you to get them from a third-party certificate authority. These are very commonly used within SQL Server. They're used to encrypt symmetric keys, secure and encrypt connections, whether you're talking about something like Service Broker. Service Broker can use asymmetric or can use certificates to encrypt connections. It's just one example. You can use it to sign packages. You can use it to also create database users that don't have an associated login. You can use that for some high security applications where a specific person shouldn't have ownership of something. There's many, many uses for certificates inside of SQL Server. It's definitely a good thing to get to know. Okay, let's see how some of these work. So we're going to use our demo database again. This time we're going to create a special type of key, which I haven't talked about yet. We'll get to this in just a moment. It's called a master key. There's also the master key that I'm talking about at this point is the master key contained within each database. It's also called the database master key. There's a second type which we'll also talk about in just a minute. You create your master key the first time that you actually use it within a given database. You create it by giving it a password. And anytime you create any sort of a key, you want to make sure that you're using some sort of a strong password. In this case, I'm just using a short one, but it's random numbers and letters. I'll typically use a much longer passphrase anytime that I create it in a real situation. So let's go ahead and create our master key, and then we'll back it up. I mentioned that any sort of a certificate can be backed up within SQL Server. It's extremely important that you do so. You want to make sure that when you create a certificate or create a master key that you back it up immediately to a secure location, and that, again, you encrypt it by a strong password that is not the same one you use to create the master key itself. Anytime, and it's also a good idea to back these up occasionally on some sort of a regular schedule. And the reason for that is that way, if somebody does change the master key for one reason or another, you have that copy of it at that point in time, even if they forgot to take the backup themselves, because it's very, very important to keep all of these on hand. Now that we've created our master key, we're going to create our certificate. You notice I don't pass a passphrase or anything like that to the create certificate command. If I don't pass a passphrase, it is going to be encrypted by the master key, and that allows it to be automatically decrypted anytime it's called. And that's actually very useful because then nobody has to know the password that you used to create the certificate. Anybody with permissions to that specific certificate will be able to use it. So we'll go ahead and create that certificate. And now I'm going to create a symmetric key. And you notice here again, I also don't pass a passphrase. I just tell it that I'm going to encrypt it with that certificate. And again, this allows it, just like on the certificate, to be opened somewhat automatically without actually having to know that secret that was used to create it. Like the hash, we're going to tell it what algorithm we want to use. And I'm going to choose the strongest one available to me again. In this case, it's the AES 256 algorithm. Okay. Now we've got all the pieces in place. Like I did with the hash, I'm going to create a stored procedure which allows anybody to use this. I'm going to start by opening the symmetric key, and you'll specify here decryption by certificate, and specify that certificate that you use to create the key. And then down on my insert statement, I'm going to use the encrypt by key function to actually encrypt that data. One thing you'll notice here is that the first parameter is actually a GUID. It isn't an object reference for that certificate, or for that symmetric key. It's actually the GUID for it. And so you have to, the easiest way to find that out, to find the correct GUID, is to use this key GUID function. And then you pass the name of the symmetric key or asymmetric key or what have you in as a literal. And then you can pass the phrase that you want to encrypt in as the last value. Okay. And then it's always good to do your garbage collection and close up things after you use them. Go ahead and create that. I'll show you how it works here a little bit. I'm going to start by encrypting several different credit card numbers, and these are just garbage ones that are that I created with a generator out on the internet. Just test ones. And if you look to see what we have here, like on the hash, we have really it's just garbage. It looks like to our eyes now. One thing that I like to do when I'm storing something like credit card numbers is if this is going to be accessible to some, like a customer service rep or something like that, and you want them to be able to validate the credit card number, store the little piece of data that you want them to use. So in this case, the last 4 digits. It prevents you from having to decrypt that data any more often than necessary. In order to decrypt that data, again, you have to open your symmetric key the same way you did before. And then you pass the decrypt by key function. Now you notice here you don't have to pass the key GUID again. It just uses whatever symmetric key is open. And then you also you have to pass this into the convert function, because otherwise it will stay as a var binary. Remember I mentioned earlier that's how you actually have to store any sort of encrypted data, as a var binary. You convert it back to car16 so it can be viewed, and then it pulls back up. If for whatever reason you have the wrong symmetric key open, this last column here where I decrypt that data will be blank. That's how you know that there's something wrong. It won't actually return any errors. And again, that's part of protecting it from people trying to break into it. Okay. I mentioned the master keys. Those sit at the top of what SQL Server calls its encryption hierarchy. They encrypt everything else. The first of those is the database master key. That's the one that you're going to use most often. You have to make sure that one's created in the database before you actually do encryption within any sort of a database. Like other types of keys, these can be encrypted by multiple passwords or multiple methods. They're automatically decrypted. They're used to encrypt everything. Over the top of those, you have the service master key. Service master key is a special type of key. It's actually automatically created the first time it's needed anywhere on an instance of SQL Server. You never actually touch the service master key. There are certain instances where that service master key may change. One of those notably is if the SQL Server service account has to change, your service master key will be regenerated. There are ways to back up and restore the service master key, but it's rare that you'll ever actually have to touch that. The sole use of that is to encrypt the database master keys because something has to be on top of the hierarchy. All right, that's all about in-column encryption. As I mentioned, that's the type that you'll use most often. There are two other general categories of encryption in SQL Server. The first of those is at-rest encryption. This is really just storing the how it stores the encrypted data on disk in a mass fashion. There's two ways that SQL Server implements at-rest encryption. One of those is for backups. Starting in SQL 2014, you're able to encrypt those backup files so that when those go to tape, when they are sitting on disk, that they cannot be easily read. One important thing to note about backup encryption is that the original certificate used to do the encrypted backup must be present when restoring. If you rotate your keys, make sure that you keep copies of the old certificates so that you can restore it. If you don't have the right copy of the certificate, it will not be able to be restored. The other type is transparent data encryption. This has been around for a while. I believe it was implemented in SQL Server 2012. It's an enterprise-only feature, but what it does is similar to a full disk encryption, in which many companies are implementing on laptops. It encrypts the entire data file, so that anytime that data is sitting on disk, it is fully encrypted. Now, you can use this in conjunction with backup encryption. If those backups are swept to tape and it's encrypted there, you can use it in conjunction with that. You can use it in conjunction with in-column encryption. Multiple layers of encryption are not necessarily a bad thing. Transparent data encryption is very, very easy to use. You set it up once, it all happens in the background, and it remains encrypted until you tell it to do otherwise. You don't have to change anything in your applications. Because the data is decrypted when the page is read from disk and re-encrypted when the data is written back to disk, the application doesn't know that the data is encrypted, but it does provide strong encryption to protect that data while it is at rest. There are a couple of side effects to this, though, and depending on your application, they may be detrimental. The best thing to do is to just test this to make sure that it's not going to reduce the speed enough that it's going to cause a problem. It usually doesn't, but always test. The first of these is that the transaction logs are encrypted. The second is that tempdb is encrypted. And if you think about it, that makes perfect sense. If you have data encrypted in one place on disk but decrypted on another easily findable place on disk, it defeats the purpose of encryption. So SQL Server automatically turns both of those on the first time that transparent data encryption is enabled, and it removes that tempdb encryption after the last one is disabled on an instance. Okay, there are a couple other limitations to transparent data encryption besides the enterprise edition only restriction. One of those is that there is a small impact on CPU utilization. Most of us don't have a big CPU bottleneck, but it is something to be just to be noted and to be evaluated anytime you're considering using this. The other is that a couple of convenience things that we can do, instant file initialization, for example, cannot be used with TDE. and file stream data is not encrypted by TDE as well. The last major category is in-transit encryption. And that is while the data is moving over the wire between a client and a server or between two servers. SQL Server provides one method natively of doing this, and that is SSL, the same sort of SSL encryption that you use when you are passing the data over a web browser. The problem with SSL is that there can be a lot of overhead if the connections are constantly being opened and closed because it is a connection-based protocol. And so many administrators will recommend that you set up a persistent VPN tunnel instead in order to reduce that overhead. Neither is better than the other. It is not necessarily necessary to do this, but it can be another method of encryption you can take advantage of to help protect your data in transit. I mentioned that you want to make sure that you protect your keys. Sony found out the hard way how important it is to protect your keys. Like many companies, they probably thought it was secure enough to have a location inside their network only accessible to authorized users to store these things where they can be easily shared. However, it's really not. You need to make sure that you protect these just as much as you protect any other key, any physical keys, any other really proprietary secrets. Because here's the thing, there's two problems with it if you're not protecting your keys well. If you lose the keys, you are not able to decrypt that data. This is not easy. It's not easy for a hacker to decrypt, but it's also not easy for you to decrypt. If you lose that key for whatever reason, if it gets corrupted and it's the only copy that you have, or it accidentally gets deleted, you essentially lose that data. The other problem is that if you have these keys accessible to someone, even if it's only for authorized users like Sony found out, if an attacker happens to get a hold of that key in one form or another, you might as well have not encrypted your data in the first place, because that allows them to easily break that encryption. So protect your keys the best way you possibly can. Find some sort of a secure location and keep that access to a minimum. This isn't something that everybody in your IT department needs access to. It's not something that I would even argue that all of your administrators need access to. 2 or 3 trusted people. It's probably about as many people. If you can convince your administrators and your management of that, those are the only people that need access to those keys. Always, always, always back up your master keys. I can't emphasize that enough. Anytime you change them, anytime you create them, and I would argue even on a regular basis, make sure you're backing up those master keys, because without the master keys, again, your data is not accessible. And if you're talking about restoring something to another server, you're going to need a copy of that actual master key. When you do your backups, always use a strong password to secure the key files. Make sure you protect that password just as much as you're protecting anything else. There's a technology that you can use to help yourself with that, and that's called Extensible Key Management, and it has built-in support in SQL Server. This is an appliance out on your network that this is an appliance out there that will generate, store, and manage those keys for you. The advantage to Extensible Key Management is that because SQL Server plugs directly into it, and you don't need to generate the keys yourself, and no one person has direct access to all of the data. You can use this to help with separation of duties, and you can use it to help manage keys more easily than creating a directory or creating a database or some sort of removable drive or some sort of other manual process for maintaining all of these keys. Because once you get into encryption, you're going to find that you will have a lot of these. Now the nice thing is that even even though these appliances have been fairly expensive to purchase and implement in the past, the cost is starting to come down, and there are now cloud alternatives out there that are becoming much more affordable. And one in particular, Microsoft's relatively new Azure Key Vault that's out in preview, even does away with the hardware security modules that you used to have on each individual machine where you wanted to use the EKM device. Instead, they have a software connector which allows you to use it. This, I think, will make it much more accessible to many more companies to use EKM, and it's definitely a technology to investigate. So just to review, all of us probably recognize the name Edward Snowden now. Many of us probably know what he looks like. The revelations he has been producing over the last couple of years as a whistleblower have really drugged this out into the light and made it obvious what even governments are doing that we need to be aware of. We need to make sure that we are taking advantage of all the tools at our disposal, because it is not possible, even with all the perimeter security, even with subdividing our networks, even with encryption and all of these other tools at our disposal. There is no combination that makes it completely impossible with today's technology to completely eliminate the possible of a breach. It just does not exist. The attackers at this point are still one step ahead of the defenders. The best thing you can do is to mitigate the intrusions by making any data that they might steal useless. Make them work for it. Make it as hard as you possibly can for them. The encryption tools are readily available. They are not expensive. They're not as hard as we think. So use the tools that you have available to you. Any questions? Vicki, do we have any questions?
Sorry, Ed, I was muted there. We do have a few questions.
Okay.
Which version of SQL Server support encryption data types? Does SQL Server 2005 and 2008 support that?
Yes, everything from SQL Server 2005 and higher support encryption.
Great.
And there were certain methods in SQL Server 2000 and before which also didn't support encryption, but really most of what I'm talking about came about in 2005 and later.
And we've also had a few questions from attendees wanting to get a direct link to the scripts that you've been using in your presentation. Now they can get PowerPoint presentation from the 24 Hours That Pass website if they look for your session. But is there anywhere else that you direct them for information on the scripts?
Sure. The scripts and another copy of the slide deck will be on my website at Leighton-Dick.com. Just go to the presentations page.
Great. Okay. Let's see here. The question is, how does it affect the size of backups, especially on 2014?
Encryption does increase the size of the data on disk, and that's because instead of storing, for example, an integer column which takes up 4 bytes, your encrypted data might, depending on the algorithm you use, will probably take up a little bit more space. You do need to pay attention to that and allow for that. But because the encryption algorithms each store data in a little bit different manner, and they all come up with a different size for the encrypted data, I can't give you a specific ratio, but it is increased.
Great. What advice would you provide to a management team from a banking institution on TDE? Most believe it is very resource intensive.
The last company I worked for, it was actually a financial institution. And we did use transparent data encryption on a number of our databases, and we were continuing to roll it out to a number of others just because it is a very effective use of that. It does have a little bit of CPU overhead, but the amount of CPU overhead was a very worthwhile trade-off. It's generally only a few percent is what we've noticed in our experience. It's a very worthwhile trade-off, and you get encrypted backups as a nice side effect to that. So it's definitely worthwhile.
Awesome, thank you. If you use Visual Studio database projects, does the key data get saved in the project source control?
The key data is, I'm assuming by that they are asking about the encryption key itself, and in that case I don't believe it would. Normally the administrator is going to, your database administrator is going to create that encryption key for you directly on SQL Server. Or if you are doing it yourself, you'd create it directly on SQL Server. You would still want to make sure that you back up that key that you create. Now, that said, if you're creating a symmetric key with a password, that source code would show up in your database project, but the key itself I don't believe would.
And do you have any EKM appliance recommendations or experiences that you can share?
I don't have any specific ones, no.
Okay. Is it possible to use in-column encryption in a column which is full text indexed? For example, patient name column which needs to be encrypted at the same time searchable by the full text index.
Unfortunately, no. You're not able to, because that data is encrypted when it is stored in that column, the full text engine would not have anything to work with. So.
Great. Now you may have addressed this question already, but what is the performance impact with the encryption?
Like transparent data encryption, there is a little bit of CPU overhead, but really it's minimal, and most SQL servers that I have worked with both in my consulting practice and in previous jobs have plenty of CPU room available to work with. So it's generally not an issue, probably just a couple percent.
Is there anything different when it comes to encrypting tables pinned in memory?
Actually, I don't know the answer to that question, but it's something I can look up.
Okay, great. That's perfect. And is SQL Server encryption PCI compliant for storing credit card data?
As far as I know, yes.
Okay, just a few more questions here. Is it overkill, or are there any advantages to enabling TDE and encrypting backups natively? As you just explained, backups are automatically encrypted when encryption is enabled.
Is it something that you have to do? No. But just like any other sort of security, I think there's a large benefit to using a multi-layered security approach. And so it definitely doesn't hurt anything to have the database that has columns that are encrypted with TDE, and then the backup of that encrypted, and if you send that backup to tape, also encrypted there. There's nothing wrong with doing that. It's a matter of your company's security policies and how far they want to go. But it definitely doesn't hurt anything.
Okay, great. And we had one last question from someone who said they'd heard that compression didn't work with TDE. Is that correct to your knowledge?
That is correct, unfortunately. And the reason for that is that the way SQL Server implements compression is that it looks for common patterns in the strings. Unfortunately, when you use TDE, it does not have any patterns that it can find anymore, because all of that is compressed as it goes to, or is encrypted as it goes to disk. So it's random. So unfortunately, that's correct. Compression will not work, and backup compression will not either.
Okay. Well, that was the last question that we had, Ed. So I want to thank everyone for attending Protecting Your Data with Encryption. Ed, I'd like to thank you very much for your time and your expertise. And once again, I'd like to thank our presenting sponsors, Microsoft, Cisco, and Dell Software, and our supporting sponsors, SQL Server, SolarWinds, and HP, who bring this event to you for free. We've hoped you've enjoyed this session. Follow along on social media with @Pass24Hop and share your thoughts on the event and any of the sessions that you get a chance to check out with hashtags 24Hop and hashtag SQLPass. Stay tuned for our next session, which will be kicking off in just a few minutes, Optimizing Your Data Warehouse for OLAP Processing with Konstantin Melamum. That will be starting in just a few minutes.
Thank you, Vicki, and thank you everyone for attending.
Thanks, Ed.